Celia and Drew. So now we'd like to gauge the reaction in the room. But first, while we put the questions on the screen and we come back to you, I'd like to turn to our distinguished panel who've been keeping an eye on the gender balance up here. So for their reaction from a regional perspective, how the decision makers in their regions may react to such a study and whether the study is fit for purpose. So I'll turn first to Bidya Pradhan from ISIMOD, the International Centre for Integrated Mountain Development based in Nepal. And yeah, but first of all, what's your reaction to the study as set out? And how do you think that your policymakers would appreciate the type of information that we're going to supply? And will it make any difference?
Thank you, Kevin. Firstly, it's we have been doing some sort of study, but this is one of the comprehensive study that we are, as you have already pointed out, bringing climate change, air pollution, SLCPs together. So there's studies. It's not that there aren't studies done, but there are studies done in bits and parts. But this would be one of the combined one where you can find a lot of information and also the ways how we could really tackle those issues. So that could be one of the reports that could be an eye-opener for the policymakers. And also, because I said the region, unless that we collaborate, we are not able to, solve this problem. So this could be one of the elements for this collaboration. And I would want to give you one example because I said there are some studies because when we did the HKH Hindu Kush Himalayan assessment, there what we have said is 1 degree is even hotter, even for the Himalayan region because of the elevation. Elevation on the mountain is much higher when it's in the downstream 1.5. So, if this goes on, then by 2100, half of the ice will be melting. Then what would be the scenario on the agricultural front, on the hydro front, because we are investing billions of dollars in the hydro, making these hydropowers. And if there's no ice and water, then what is the use of it? So these are some of the, triggering questions that even in the assessment report, if you could, have these things. And we done a little bit of study on the bricklin sector that I just wanted to mention on this. It's, we try to do from the type of return of investment if they are converting their old traditional kilns to the more cleaner kilns, brick kilns. So what would be the return of investment? And we also mentioned that was for the private sectors who we encouraged to build, because there was a huge, as you have also mentioned, when we are doing these things, there's a huge upfront cost that we need to also look into it. Converting one kiln would cost around $100,000 and that is not a very, minimum cost that they could. But how do we really like to, portray this? Because there are certain benefits, there are benefits that is involved in this conversion, saving of the fuel, better bricks, the time consumption is less. There's a climate benefit, now we are able to, if you talk about Pakistan and Nepal, converting fraction of kilns itself is 1.6 million tons of CO2 reduced annually, and likewise BC, black carbon. So these are the things that we get from the policy level. So the policy is, really wanting to have the policy change in making this brick kilns from the policy angles. They are not allowed to operate the traditional kilns. That was the, message from the policy angle. For the brick kiln, it was the, return of investment that able to return within 2 years. But, what is the risk of inaction? Then, that we had to really, not in the same way as cost of inaction, but we said like risk of inaction, what will it have? So those are the things like the social cost, the economic cost, and the environment cost that we said it's a trifecta benefit when you do it, all these things. So these are the things. And we need some example for the policymakers and the decision makers and even the politicians to convince these things, because the numbers would really, really help. And I think like in this assessment, if we can get some numbers, that could really, really help. And some of the things like, some examples that could, you have already done somewhere. So that could help them as an eye opener and be motivated to do further things. Thank you.
Thank you, Bidya. That's excellent. So I'm hearing that there's, specificities about the South Asian region, and especially in your part of the region in the cryosphere. So what's going to happen to the glaciers is a really important thing for us to think about, and all the implications. And then the specific issue for the brick kilns and the costing of that. So thanks very much for that. So turning now to Beatrice Cardenas, who's sort of representing South America, but also with a World Research Institute hat on. Can I get your perspective on whether you think the study as proposed is fit for purpose, and what any particular gaps you see? And the floor is yours.
Looking forward to see the report. What can I say? I mean, it's like, wow. I think that we need stronger and clear messages. We have been talking about the integrating climate and air pollution, but I guess we need more and more strong facts. I think that's something that I mean, regarding of the title, I think that we need some support from our comms specialists, something that is more powerful. This economic assessment sounds like the economic that the report that only the economists read. And the cost of inaction, I like that. Like, what is the impact of not doing what you have to do? But implementing short-lived climate measures is like, yeah, do it. But so I don't know. I think that has to be like really communication base, what actually triggers, and maybe that should include like a research of a literature review on what type of messages have captured the attention not only of people but politicians and decision makers in the region. I think that sometimes some of the decision makers, when they come back from conferences or even some interviews, if they are being asked for some questions that they cannot answer, like what will happen if you don't do this, or what are the consequences of doing this that late. So I think that will also, and will give some spotlight to air pollution, that we know that every time they come back from the COP, they are so eager to do so many things on climate, but if you ask them what are you doing on air pollution, they don't even know the connection. So I think that will be very powerful. I think that also that is very powerful is to talk about the regional disparities, that everybody knows who will have the impacts of climate change. What about air pollution? I think not doing what we have to do in an urgency is who is getting the most impacted. So it talks about the disparity within our world, and what are, particularly the global south, what is missing, what is losing of not doing this action, integrate action. And I think that, things like the rain, crucial thing for everyone, but particularly in the global south, and biodiversity. I think that is also something that usually is not connected to air pollution. But if you see the UNEP convention, the air convention, biodiversity has been always been there, but it's not in the discussion when we talk about air pollution in the global south. And again, also focusing on people, which is that's the main issue. What will represent of not doing. And then in terms of barriers, I think that in addition to the ones that you have identified, the social and institutional barriers, it's important to see on the political barriers, and considering how the political mapping is changing, and maybe even doing some forecast what will happen if this, what will happen if A or B. And yes, I think in addition to this just transition, focusing on inequity and definitely bringing something on gender. So again, if you see that the examples of what will happen of women if you don't do the clean cooking, that's a very simple example that everybody can tell. But if you ask what happened in terms of gender and women, and particularly in the Global South, by not doing action on integrated action, it's difficult. I think we need more of that strong facts, or at least being covered or analyzed. What is the what will happen if you don't do this right now in terms of getting the shortening the gap in terms of gender and access to jobs and access to education and many other things, or health.
Well, you set the bar of expectation high there, but they're all really, really good points, all very good points. So thank you very much, Beatrice. So moving on to our third panelist, so Kenza Chomzi from Morocco, representing North Africa, perhaps the whole of Africa. So I ask you the same question, your general reaction to the study. Is it fit for purpose for the policymakers, and have you any special recommendations? The floor is yours.
Thank you so much, Kevin and Beatrice. You made my life easier, and I agree so much with a lot of what was said, mainly when talking about the strength of messages. And I will start from the first quote that was in the first slide in the presentation of Tatsuya, who said that the benefits of strong and early action far outweigh the
Kenza, could I just ask you to talk directly into the mic, because I think it's not quite picking you up.
Yeah. So I was sharing the message in the first slide in the presentation, when it is said the benefits of strong and early action far outweigh the economic costs of not acting. And then here we have to dimension the intensity and time. So when we talk about time, it's clear. Time starts in a point and finishes in a point. But strength or strong action, what does it mean? So intensity, what is the scale of intensity for an action? So again, what I want to mention here is what kind of narrative are we giving to the decision makers? What are we telling them? And also I liked the cost of inaction. So I said, okay, scientists decided to be less nicer, or yeah. Because in the beginning we were talking about, it's kind of, we were vibrating between the carrot and the stick. So in the beginning we were like saying, this is the benefit. Hey, this is the co-benefit. This is beneficial for you. And then this is kind of carrot. And today we are saying this is the cost of inaction. So you need to take action. So it's kind of the stick point of view. So again, I think what we need strong narratives. We have all the evidences we need, and we need strong narratives to offer and to be convincing. And also the point of yes, the work started on SLCP years before, and a lot of progress have been done, and we have a lot of things also to understand related to all the interconnections that are there, and understanding all the interconnection is something which is challenging for scientists. This is for sure. And it is more challenging for decision makers to be understood. And in the morning, the question about aerosols in Africa just made a beautiful debate and confusion as well. So this, if it is the case for scientists, it will be more difficult for decision makers. So I think, again, just to emphasize that in the narratives, we need to be more convincing, and also while talking about SLCPs, we have opportunities there. And I think that the CCAC is great in explaining the opportunities, but also we need a readiness to answer all the questions, because sure there will be questions behind. So this is one thing. The other thing that I want to mention is, we know the policy making cycle. So it started from the problem identification, the agenda making, the budgeting, the implementation, the evaluation, and then the problem. And for a while, scientists were always in the problem identification, and we had the habit to talk about problems and stuff. So when we see a scientist, we are like, this is a problem. Okay, so for us, science is always source of problem. So today, again, with the SLCP, we are advanced. We are in the Asian market. Today, I'm happy to listen to the economic assessment. So we are a little bit in the budgeting. So when will be in the implementation? And I think that this is the most challenging point of it, because we are often part of the solution, but the implementation is what is really challenging if we want to take everything to the ground. And I know that today it is very recent that we start talking about the implementation science. So I know that it's a question of time, but again, we need to be ready to go ahead with bringing this to giving information about the implementation. And again, one of the things that I like talking about is the policy entrepreneurship. And we know that we have streams when we are dealing with policymaking, we have streams. We have the problem stream, the policy stream, and the politics stream. So are we really taking all this into consideration? So yeah, I think that this is the most challenging. Otherwise, I really congratulate my colleagues in the SAP for this work, and thank you for the SAP for the support they gave for this for such works. Thank you so much.
Thank you so much, Kenza. So you've pointed out some very key challenges for us there, but yeah, it's getting that integrated approach to the whole thing, including the politics, which is a real thing for us to try and grasp with. But I think we've got power in the room. So now we move to the room, and the panel, feel free to come back in if you want more clarification. But so we'd like to judge the reaction in the room there. So can I see any hands? So yes, the floor is yours. Could you say your affiliation as well, please?
Yeah, thank you. My name is Alin from University of Indonesia. I have several questions. First is, what things need to be done to overcome regional difference issue? I assume it relates to how to make parameters and data fit into regional context, and how to localize parameters. What are crucial data needed that is most likely will impact significantly the result of the model estimation if we don't consider the difference. For example, maybe we need to conduct a value of a statistical life survey in different region, considering the lack of this data in most of developing countries. Next, can we generate what so-called marginal abatement cost of each policy or intervention from the model? The third one, can we interpret the cost of inaction as the cost of delaying action? This already mentioned by one of the discussion. It is possible to generate numbers, for example, like the cost of delaying certain action per unit of time, for example, like per second or per year. Next, regarding policy inventory, if we overlay the climate action and clean air action, how similar are they? And the last one is, if we want to bring this study to the financing aspect, what are the strategy and whether there are possibility that we can mobilize private financing, given maybe some of the action fit into the private interest? Thank you.
Thank you very much. There's 5 interesting questions there. I don't know if Tetsuya or Drew, you want to pick up on them.
Thank you very much for those questions. I didn't catch all of those questions. But firstly, how to overcome the issue of lack of data, especially about the local data. Yes. When we conduct a global modeling, then we always face with the lack of data, especially in some developing regions. So in such a case, we need to use the average data, but for this study, we need the support from our every country to set some data source, and then we would like to include the local parameters as accurate as possible, as many as possible. That is one point. And next, by using the bottom-up type model, then, like you mentioned, then yes, we can analyze the marginal abatement cost, mitigation mitigation by mitigation option by option. Yes. So yes, but it depends on the resolution of the model and also resolution of the resolution of the region. So it depends on, yes. Also, if we can supply the detailed enough to the regional policymakers, so it depends on, yes, limitations and the possibilities of the each model. And the last part, cost delay. Cost of delayed action. Yes, we didn't conduct this analysis yet, so I'm not sure how detailed we can provide data. But yes, I think that's okay. If we delay actions like 5 years, then we may get this kind of the impact. So we may be able to discuss the cost of action and the cost of inaction in the resolution of years, not like a day or the months. That's my first impression of
Yeah, thank you. There's some very interesting questions. I'm not quite sure I understood everything, but the parts that I feel I understood was there was a question about whether, we evaluate the damage per unit of change. And that's a really interesting one. And I think we know already that damages are highly nonlinear with the amount of climate change. I don't think that that's obviously the case with air pollution as much, but with climate, we know that that's going to be an important factor. So, a sum of a bunch of marginal impacts is not going to be the same as looking at a bunch of impacts together, which I think will be a good question to think of. What kind of scenarios do we need to do this? Is it the cost of inaction under a baseline scenario that has a very high rate of warming? Then you would get a much higher cost of inaction than a baseline scenario that assumes a more sustainable world. So I'm glad you raised that. I think it's going to be a good thing to think about. I guess the one other thing I can comment on briefly is the question about air pollution and climate change damages, and are they similar? And I would say that there is overlap because they affect things like human health, both of them, which tends to have an outsized importance in the overall damages because people value health so highly, quite sensibly, I would say. There are also areas where they're quite distinct, where climate change, for example, affects something like sea level rise, which just isn't an issue with air pollution. And I think that also leads to the conclusion that the impacts of climate change will have a much different uncertainty profile, where they will be much higher than impacts associated with air pollution, for which we can quantify a bunch of very discrete pathways. But things like high impact, low probability events like ice sheet collapse raising sea levels by many meters are something that's going to make that the distribution of potential climate-related damages very different from the distribution of air pollution-related damages. So I think they're great things to think about.
Thank you very much, Drew and Tatsuya. So I think we had a question from Zig.
Thank you. Great comments so far already to this proposal. And I have a very basic question. Maybe I missed at the very beginning, and a couple of other comments and questions, if you allow. So the first one is about CO2. So when you speak about the first line here, says air quality and climate damage, proposed titles address SLCP mitigation. So I just want to understand if the mitigation scenarios would include focus on SLCP that will not cover all CO2 mitigation opportunities, or they will include all CO2 mitigation opportunities and those that are dedicated sort of SLCP. It was just not entirely clear to me if this is SLCP on top of something, and then how do you actually discriminate between what can be avoided by this or the other bit, because there's of course co-benefits on CO2 as well from all of it. It's just my maybe I didn't quite catch the very beginning of the presentation. Now the title, because the title also has SLCP in the title, I thought basically a nice title could be like a newspaper title, Cost of Doing Nothing. Maybe that's too drastic, but maybe people would turn, on the street reading this somewhere being announced. But in terms of setup, there's a lot of questions that are actually coming down to this very fine resolution, because of course the interest from the impact perspective would be coming from these communities, sub-regional countries. And so I wonder how far you are in the design stage of thinking. You talk regions like climate models for the IPCC, when you have either geographical models like the AR6 have a different type of regionalization in terms of impacts, or you're going really down then into downscaling of the results, which probably would be super important for carrying forward the message to country level or even sub-country level, which brings in a lot of complications in terms of probably models that need to be used for that. So that's one question about this level of regionalization for modeling and creating the scenarios. In terms of scenarios, is the plan to have, you Drew just said now on a baseline and then some mitigation, but is this like one or two mitigations, or you talk like IPCC about a number of models being used to develop and cover a little bit of uncertainty, because each of them, obviously, we don't know exactly which, how the measures will be what the measures will bring. I know it can be addressed, like in the previous assessment, CCAC assessments, that actually there wasn't a big probabilistic analysis or uncertainty covered with a lot of scenarios, but rather addressing uncertainty of specific aspects that are included in the scenario, which I'm all for as well, but just wanted to know what the plan is. And maybe to stop now, we have a number of other questions probably for the coffee break. But what is the timeline of that? How quickly you want to achieve that? And is the team already behind it set up, or this is going to be a call? So very practical questions. One very important question from my perspective. How, if at all, does it connect to, say, AR6 SSP storylines? Would this be a resource, at least in terms of SSP futures? I know there's been a lot of critique on that, of course, but there will be also a lot of critique on the future AR7 design. Or does it connect? Is the plan to connect to the community, IPCC community, that has started discussion in Bangkok actually a few weeks ago on the design of scenarios for AR7? Maybe that's out of timeline, I don't know, but that could be one possibility. And the other one that is, I think AR7 has on the plan the dedicated special report on cities. I mean, if this is done in parallel, and I think that city report was supposed originally to start, 25 or something, and done probably in 2 years or so, I mean, that could be a very good possibility from the stakeholder perspective and those who are acting on that level, if that is coming sort of at about the same time and brings in message that could be maybe downscaled. I was wondering if the atlas that IPCC has developed for AR6 could be actually a useful tool also for illustration of some of the results of this report. And so truly last comment, the per second, changes per second. There's actually an interesting project from, I forgot the name of the company, but they've done it with support of German government. And there's something like called World Clock. They looked into emission. They looked recently into, before into poverty. So there's a tool that actually pulls information from different scenarios and current level of emissions, and it's ticking. It shows who is emitting this second, whatever tons. They say this was a powerful illustrative tool for just illustrate the dimension of change or how much behind we are, behind our own promises we are. Because then you can put it in perspective of how the clock should be working to deliver what you promise and how far away we are getting. And this is like quite funny because for scientists, this is very crazy. And you get on extremes, completely crazy stuff in there. But in general, it's for many, it's quite interesting, I think. Thank you. Sorry, thanks for giving me so much time. Not cutting
Thank you,
my
Zig,
mic.
for your encyclopedia of questions. So who would like to have a first crack? I wrote them down if you want some assistance.
-1 minute to answer
Yeah.
the question.
So what we're going to do is, if you allow, Nathan, is we'll take some answers to these questions, and then if there's any burning question in the room, I'd like to take that as well, if you're happy to. Is that okay? And then so go.
Okay, I will answer very much some questions very much quickly. As for the coverage of gases, yes. Firstly, we need to discuss the how to achieve the 1.5 degree target. So CO2 should be included. Without CO2 reductions, it is impossible to achieve the 1.5 degree target. So what we want to know is the role of the SLCPs. So in addition to the deep reduction of CO2 towards the carbon neutrality, we want to know the role of the SLCP. That is one thing. And second, as for the model, a type of models, those are under discussions now. And third, the number of scenarios. Yes, in order to simplify discussions, then I only showed the baseline and mitigation. But based on my experience, even if we project the same CO2 projections, that depending on the different combination of mitigation measures, the emission projections of non-CO2 are very much different. So I think that we need to consider the key mitigation options and policies. Then we need to set the several scenarios in this study. But we haven't discussed the number of scenarios yet. Okay, thank you very much.
Okay, so let's give the room one more chance if there's a burning question. Otherwise, we'll wrap up for coffee. Did I see a hand? Okay, no. Okay, so I'll hand the floor over to Nathan.
All right. Again, the person who's not very good at speaking in short sentences, a little bit like Zig. I appreciate those questions, Zig. We're going to have to interact with you a little more closely in the coming couple of hours.
That's our first agenda for the next meeting is Zig's questions.
Timeline wise, we need to finalize this, come up with a budget and the team, which we have not developed yet, for final approval by September. The board meets again in September and will be approved then. And then we will begin with great earnest on this. So this is a process. We welcome everybody to be part of this. And so if you have any feedback or questions, please come to us and we will be receptive and welcome the collaboration. Thank you again for joining us. We have one more session after the coffee break on connecting monitoring to action. I absolutely encourage all of you to come back. The coffee is just right outside the door, so it's not much effort to turn back around and come in here for the final session of the day. So thank you again. Please enjoy your coffee. Oh, yes. And yes, let's clap for the speakers one more time.
Mm-hmm. เช็ค1 2 1 2 1 2เสียงในทีมเข้าปะ OBS เข้าปะ OBS เข้านะ OBS
And so she'll be able to hear through the audio system.
Yes, audio check. 1, 2, 3, 4, 5, 6. Audio check. 1, 2, 3.
Hello, everyone. If you could please take your seats. We're just about to start with this very last session of the day. We managed to get so far. So, yeah, we have a very busy session, so I guess we better get started. My name is Michel Grutter de la Mora. I am from the National University of Mexico, and it is for me an honor to moderate this session about connecting monitoring into action. This is a quite important topic, actually. As we have been hearing throughout this meeting, that we have a great challenge in terms of air quality and climate, but we have to say we also live in a very exciting era, the era of satellites and Earth observation systems. And it comes really timely because we really need every tool we can use in order to really bring action into mitigating the emission of greenhouse gases and SLCPs. So really the technology has advanced in such a matter that really it's revolutionary, as one of the titles of the presenter says, making the invisible visible. And it is really, I like this sentence because satellites are giving us really a way how to see things that we were not. And it's changing the way we see our planet. In this sense, it's really revolutionary. So for some time, we have had lots of instruments on board of satellites giving us images, like in different spectral bands, looking at really the characteristics of surfaces, and then clouds, water vapor, and so on. But now we have more sophisticated instrumentation, spectrometers, which are able to measure radiation, solar radiation, which is reflected in the Earth's surface, and measure the information of the gases through their spectral signatures. And from that, we now have a very comprehensive information of the spatial distribution of certain gases, which we really need in order to identify hotspots and look into possibilities and opportunities to mitigate gases. So in this sense, I don't really want to take much time of our panelists. We have a very excellent group of panelists to guide us through what is really the objective of the session is to see what our current capabilities are, and then see how we can use and evaluate the tools that we have in order to bring these things into action and really make some change into what we can do. So we have Ilse Aben from the Netherlands Institute of Space Research and Casey Hoffman, Director of Strategy and Partnerships from the Carbon Mapper, who will give us some overview of the different technologies available right now. Marcy Rose Baransky from the International Methane Emission Observatory will talk about really interesting tools that are now available to use this data. And then we have two country examples from Kun Foranush from the Department of Environment in Thailand, and Jose Abraham Ortínez and Suelen Padilla from the National Institute of Ecology and Climate Change in Mexico. And then we will move on to the discussion where we also have Sergio Sanchez from the EDF and Jonathan Banks from the Clean Air Task Force. So, Ilse, you're on. Please. The floor is yours. First presentation, please.
Just waiting for, okay, it's you. Okay. It's actually going to be me. All good. So this is, so as was mentioned, really, I want to focus a little bit on I'll kind of step back a little bit on the policy context and then talk briefly about the broad suite of technologies that we have and what we're focused on. And then I know Ilse is going to dive a lot more into the science and how to make that and how it's possible. So really, I just wanted to take a minute and say, you know, we're at a really interesting point in the methane conversation, and I think we need to kind of recognize where we are. There has been an incredible growth in the attention from global leaders on methane, and that is relatively new. And what is really, really exciting about that growth in attention is that it also accompanies a growing need for data in order to implement, and a need for accessible data. And so what's even more exciting is that there's a lot of advanced technologies that are either online or coming online that are going to really help to deliver that data. And so the next challenge is going to be making that data actionable and usable. But what's also especially exciting about the landscape is that in that policy conversation, remote sensing and satellite technologies are actually being looked at as a tool to help achieve those mitigation goals, pledges, priorities. And they're increasingly part of this conversation. So I know that we'll have folks talk about the UNEP IMEO's methane alert and response program, but that was huge and really brings this technology onto the global stage. Last year at COP, the U.S. State Department announced as part of the global methane pledge pathways, and one of those ways to achieve that was actually leveraging satellite data across a number of different sectors. And then we're also seeing countries start to build programs that leverage remote sensing and advanced technologies to use that data. So in the US, the EPA has actually proposed something called the Super Emitter Response Program, which is geared towards leveraging satellites and remote sensing data. And so that's incredibly important to think about how these new technologies and existing technologies are starting to really inform and guide mitigation action. This chart is also a really good example of the landscape, although interestingly, it's also outdated at this point. I think there's some things missing. So if you can just get a sense of how fast and rapidly the space is changing. But just to kind of give a broad overview, so really in terms of satellites, there is a spectrum. So some are really optimized to detect and measure methane from large diffuse area sources. And others are really optimized to get more granular and focus on targeted high emission point sources, which I know Dr. Abend's going to talk much more about. It is also what Carbon Mapper is focused on. But this is a really incredible landscape. And some are actually optimized to do parts of both. And so that is a really important element when we think about how to apply these technologies to key uses and policymaking. And so one of the big things that I think we all know here and that has been talked about is that unfortunately there is no one technology that can see the entirety of the methane challenge. And so what that means is that we actually do need to leverage all of these technologies to answer different parts of the methane monitoring and measurement question. And so really the way we talk about it is you need a system of systems, but also a portfolio of technologies. And as I mentioned, some of the tools are optimized for to see different parts of the methane puzzle. And that also means that in order to tackle the right use, you need to match it to the right tool. And so some of these tools are best suited to support aggregate emissions accounting, inventory development, so really thinking about emissions at a national and regional scale, and others are more focused on supporting direct mitigation guidance, so at the local and facility level. And to address kind of this entire ecosystem of monitoring across methane, you do need this portfolio. That also means we need to look at other technologies, including ground-based sensors, aerial sensors, and satellites, because they all kind of fit into this broader puzzle. And the other thing that is, despite the really exciting emerging landscape and all of these technologies, a number of key gaps remain. So really importantly, trust in the data and the technologies. Secondly, capacity to use the data. So there's a huge need to build more technical capacity in institutions and on the ground. And then finally, resources to scale these systems. So really, if we're looking to provide global monitoring solutions, which satellites can provide, we do need to actually think about how are they resourced in order to provide the monitoring frequency that we need. This is a little bit of, so I'm at Carbon Mapper. These gaps were a large portion of what we are designed to try to fill. We can't do it alone, so not trying to say that, but really we're working to address a lot of them. So Carbon Mapper is a small nonprofit that is using remote sensing from aircraft and satellites to fill data gaps on methane and CO2. In order to do this, we actually lead a really unique and innovative public-private partnership that brought together a whole host of actors to do something that none of us could do on our own. That partnership includes NASA Jet Propulsion Laboratory, the satellite company Planet Labs, the state of California, the nonprofit number of university and research partners. And what we are working to do is develop and deploy 2 satellites with the capability to detect, pinpoint, and monitor and quantify methane and CO2 emissions at the scale of individual facilities. And Ilse will make a lot more of this visible when she starts talking. I really hope to bank on that. But one of the big unique things about this partnership is actually that we will make all of this data publicly available and free for everyone to use on an open data portal that is currently housing our airborne data, but will soon house satellite data. Because what we are really focused on is this question of what we're here to discuss today, which is making this data actionable and usable by decision makers and stakeholders. And so I talked a little bit about the landscape and how some of the technologies are suited for certain problems. So what Carbon Mapper is specifically focused on is high emission point sources. So sources that are really large and come from really small places like facilities or even equipment, and as opposed to kind of diffuse area sources. And the reason that we're focused on this is because a number of studies have actually found that a small amount of infrastructure actually can emit emissions that disproportionately contributes to regional emissions. And so some of those studies have actually found that this handful of infrastructure contributes anywhere between 20 and 60% of regional emissions. And that's a huge opportunity. So if we're able to pinpoint where those sources are, identify them, and work with the people on the ground who are operating those facilities or sites, and we can mitigate them, then actually can have some very large near-term reductions. And it has a number of host of benefits, including supporting, public health and air quality concerns, as well as addressing climate. And we've also found that these point sources can be seen in other sectors. So oil and gas, coal, agriculture, and waste management. So it provides a big opportunity for large reductions. And so since we wanted to talk a lot about how this data can be used and what the value is, so this is a brief slide, and I'm sure we can get more into it in discussion. But really, there are kind of 6 general pathways that we talk about how this data at this level can be used. So one, as I mentioned, is direct mitigation guidance for operators and folks on the ground. It can also help to inform best practices and prioritize investments. So if you're trying to figure out where to best place your resources, it can help to identify those sources effectively. It can also help to support supply chain intensity validation and verification, and can inform gaps in policies, as well as inform and improve inventory estimates. And then because of its localized nature, really help to support and empower communities to drive action. And so, as we mentioned, one of the keys of this conversation and the data is actually getting it into the hands of those who can use it. And so this is a high-level overview of some aerial surveys that Carbon Mapper research scientists have been conducting since 2016. And so through those surveys, we've actually worked with operators and regulators on the ground to observe methane emissions across the state of California. This includes oil and gas pipelines, natural gas production, and landfill sites. And through that partnership, worked with the regulators and the operators to share that data with folks on the ground. And what we were surprised by is that a lot of them took voluntary action. Not everyone, but a decent amount. And that actually led to significant reductions in methane emissions. And then the other unique thing about this technology is that it can also be used to verify that those reductions took place. So we actually conducted follow-on surveys and were able to identify once the operators said that they had mitigated the methane emissions, that was actually achieved. And this is a really important and good goal to think about of how to use these technologies to drive action. But there are always challenges, regulatory environments that support this. That's not the case everywhere, and finding the right people to take action. This is also why it's really incredible that efforts like IMEO, Mars program, and others are actually coming online to actually start to fill some of that data to action gap. The other thing that we announced last year that is an incredible opportunity for this type of technology and application, and I know Dr. Aben is going to talk much more about this with their work as well, is we are especially focused on waste sector methane in addition to oil and gas and coal. And so over the next 2 years, we'll be leveraging airborne and satellite observations to develop a global baseline of high emission waste sites, and really looking to scale up insights into upwards of 10,000 sites globally on their methane emissions. And we hope that we can provide localized actionable data to stakeholders on the ground globally, and sort of working with folks on the ground to do that. And this is just a little bit of a deeper dive into kind of how we have started to engage on waste sector methane, and gives you a sense of how this data can be used within the sector. So it's really can be helped to use to guide mitigation and identify what sources in a landfill we can target and mitigate. And then also when we have conducted aerial surveys in the US, we have found that differences in reported and observed methane emissions. And so really helping to inform the estimates and helping to inform that process. This data can do a lot there. And then finally, as I mentioned, help to really prioritize investment and mitigation action. And then this is my last slide, and then I will hand it over. But really, this gives you a sense of both the capabilities and the scale of the different technologies and what we're doing with them. So this is an overview of where we plan to observe methane. So looking at oil and gas, coal, waste, and some agriculture, and using the different tools to really provide local insights globally. So you can see the regional aerial surveys. This is actually an old map. We have it filled out much more of where we've flown. And then we are also using other tools at the moment until our satellites go up, including NASA's EMIT satellite mission, which is currently on the International Space Station, to detect and quantify methane emissions. And then the bottom corner map shows where we plan to both do some initial global observations and then more frequent monitoring. And one of the key elements of what we're looking to do with this data is build partnerships and integrate it into efforts that are ongoing at the country level and local. So definitely looking for partners there. And one of the key elements of kind of how we're looking to drive action is we've been working very closely with Clean Air Task Force and RMI on their waste map program, as well as working with a number of countries. So we actually just recently finished some aerial surveys in Chile and Colombia and Ecuador, where we've been working very closely with national universities and the ministries to take the data and drive action and give them the insights that they need. So I know we'll have a fruitful discussion, but wanted to end there. Thank you.
Thank you.
Yeah, so I'm waiting for my slides. Or is it just me having to push a button? Oops, now I'm pushing too fast, I think. All right, so thank you. All right, so how can satellites help to take action and action now to reduce methane emissions? And in my presentation, I will focus on these super emitters that were already introduced by Mackenzie. So, this is a slow system, or okay. Right, so this field has really developed very quickly over the past few years. And a really important satellite instrument is the Tropomi instrument that we realized together with ESA that was launched in 2017. And it measures actually a lot of species in the atmosphere, including methane. But the unique thing about the instrument is that it combines daily global coverage. You see the whole Earth atmosphere in one day, while each individual observation looks at an area of only 5.5 by 7 kilometers. So let's say at city scale resolution. And that turned out to be ideal for the detection of these so-called super emitters, of which I will be showing you some examples. And the first example, I think, no. Oops, yeah, this is going to be fun. Right. So the first example that I'm showing you here was a study that we did over Australia, in particular over Queensland, which is an area of coal mining. And what you see is a single overpass of the satellite. So this is an observation that is taken in, let's say, 1 minute. And if you look carefully, you can see plumes of enhanced methane, 3 of them actually. And the most northern one actually corresponds to emissions from a single coal mine, because there's nothing else in the area. The other are representative of clusters of coal mines. And it turns out that that one single coal mine is responsible for only 1% of the production of coal in Australia, while based on the Tropomi emissions that we estimated, it actually represents almost a quarter of the reported emissions from all coal mines in Australia. So that's a typical example of such a super emitter. Now, once we saw that we were able to see these super emitters from space, sorry. Thank you. So we actually started to develop a machine learning technique to identify within our daily observations. So on a daily basis, actually try to detect these super emitters. And this is the map showing you the super emitters that we have seen in, for example, a year of data in 2021. The reason we're using machine learning is just because we have like a few million observations a day. So we have really a lot of observations to go through. And well, the circles denote the detection of the super emitters, and the size of the circle is an indication of the amount of emissions. Now, in most cases, because we look at an area of 5.5 by 7 kilometers, when we detect such a super emitter, such a large localized emission, we can't really tell what exactly is the source, because in most areas of 5.5 by 7 kilometers, there could actually be different sources responsible for that big emission. I mean, the Australian coal mine in that sense is a little bit of an exception. So what we've been doing is actually team up with GGSat, which is a private Canadian company, which measures methane at 25-meter resolution. And but it can only do that for an area of 10 by 15 kilometers. So it needs to know where to look. And that's exactly what Tropomi is providing. We basically provide these locations of these enhanced methane signals that we see in Tropomi of these assumed super emitters. And they then point to the location we provide them. And I'll show you a number of examples. And at the moment, just to be clear, this is a private company. This is data is not in the public domain, so that's an important point. And but that will change soon, later this year, with Carbon Mapper. But it's the only satellite up there at the moment that is dedicated to measuring methane at 25-meter spatial resolution. Now, having said that, since a few years, we actually know that Earth surface imagers, so let's say the Landsat type of imagers, Sentinel-2 and Prisma and a few more, are actually capable of seeing under favorable conditions also these very large methane super emitters if they actually have the right spectral coverage. And so this would be in rather homogeneous terrains like deserts with high reflectivity of solar light. So I'll actually start showing an example of that. All right, so this is that first example where we're looking at the west coast of Turkmenistan. That's next to the Caspian Sea. And on the left image, you see an average image of 2 years of Tropomi data. And the red means that we see enhanced methane. So we see a number of hotspots in the Tropomi data, which we roughly determined what the locations could be of these emissions, and then provided those to our partners in the University of Valencia, who then zoomed in with their analysis using Prisma, Sentinel-2 and Landsat in order to get the high spatial resolution image. And this is what we found in that study, is that actually these 6 hotspots, there's 29 different big methane sources, out of which at least 24 are not burning flare installations. So that's really low-hanging fruit in terms of trying to reduce methane emissions. And this is just giving you an example of zooming in with Prisma. In this particular case, on one of these hotspots, you see 2 methane plumes. And if you look carefully, you can actually see that at least one of them is corresponding to an open pit flare installation, which is not burning. Now, what we also do is we actually monitor these 29 different locations in time, and I'm just showing you 3 of those time series. And with the different colors, we denote what we're seeing. So we either conclude that it's flaring with orange, and in green, it means it's not flaring and we're not seeing methane emissions, at least not above the detection limit. And in red, we're actually seeing large methane emissions. So we can really use this to monitor what is happening on the ground. Now, going to somewhat more challenging cases, in this case, emissions from landfills. On the left-hand side, you see an image of 2 years of average data with Tropomi again. This is looking at Buenos Aires. And again, the red means that there's enhanced emissions. And again, we give the location as we determine it with our tropomi data to GEGSat, who then zoom in, and they saw the image on the right, where you see very large methane emissions coming from a landfill in the city center of Buenos Aires. And if you zoom in a little bit further, you can even see where the plumes are really coming from. So the most western part is the active area of the landfill where garbage is still or waste is being dumped. That's where the biggest signals are clearly coming from. And you can even see in a more dark purple to the east, somewhat less big methane emissions, but that's coming from the close parts of the landfill. And the interesting thing is that so we can even see from space where from the landfills most of the methane is actually escaping into the atmosphere. So, and that's very valuable information if you want to do something about this. And in this paper that was published with first co-author Bram Maasakkers, we also looked at other cities like Lahore, Delhi, and Mumbai, and again triggered by tropomi enhanced methane signals, and then followed up by zooming in with the GEGSat satellite here. And what Bram Maasakkers also did on the right-hand side, you can see that we estimated emissions not only from the landfills, as based on the images on the left, which is in the light green bars, but we also estimated the emissions from the urban area using tropomi in the dark green bars. And you can see, for example, for Buenos Aires, that half of the emission of the urban area is coming from this particular landfill. Well, we also see some super emitters in Europe, not so many, but this is an example which we always see when we pass over, and it's cloud-free. These are signals southeast of Madrid, and when zooming in with GEGSat, actually see two different methane plumes coming from two different landfills. Now, it was already mentioned, the IMEO, the International Methane Emission Observatory, that Marcy will talk about more, but I'll just mention that we are contributing to that, to their methane alert response system, by providing this type of satellite data analysis, in particular to component one of the Mars system, that is the detection of these super emitter signals, and attribute it to the actual facilities or sources that are responsible for them. And then Mars will continue to notify responsible parties that then presumably will take action once notified. But Marcy will say more about that. And the first focus here will be first on super emitters from the oil and gas sector and coal mines. A little bit more about the landfills. At the COP, we showed the map that you're seeing now, which is showing all the detections at that point in time that we had from space on emissions from landfills. So in the orange circles, there's some 40 or so of them. These are urban hotspots that we found with tropomi, which were then followed up again with a GEGSat satellite. And in the black dots, you see the emissions that were connected to actually landfills or waste dumps. And for most of these urban hotspots, indeed, we found emissions from landfills. Once we knew, you could actually see that they continue to target, obviously, more landfills and waste dumps. And on the map, you see more than 100 identified locations of large emissions. And we really showed this map to show the potential of doing this from space. And what we did as part of a study funded by the Global Methane Hub is also zoom in, or actually do a time series at 4 different sites. And I'm just showing you an example from Casablanca. You see here the typical image from tropomi, again, used to tip and cue the next satellite. And then that was zoomed in to actually see that this emission was in large part coming from a landfill. And we hope in the near future that we can expand on this study to more sites across the globe. And in this earlier study, we looked at Casablanca, Istanbul, Hyderabad, and Sao Paulo. All right, to wrap up, so I think there's an enormous potential to use satellites in support of emission reduction. These super emitters that's really the low-hanging fruit, so we can act now. but we have only scratched the surface. And I think Kenzie also already said we have to scale up this tool, basically, because the global map I showed in the beginning, we only followed up on a few case studies so far, and there's so much more to be done. In addition, we need that data in the public domain, and which is why it's so great that these new satellites are coming up, starting with Carbon Mapper and also Methane Sat. And that's it for me. Thank you.
Hi, everyone. My name's Marcy Baranski. I'm here today from UNEP's International Methane Emissions Observatory, or IMEO, to talk about our project MARS, the Methane Alert and Response System. So UNEP IMEO's MARS will contribute to IMEO's mission of providing open, reliable, and actionable data to stakeholders who have the agency to act on methane emissions. MARS will harness state-of-the-art satellite data to quickly identify major emission events, to notify and engage countries and operators, and provide support for mitigation and to track progress through time. MARS is first focused on the energy sector and will identify emissions from oil, gas, and coal activities with the ambition of expanding to other sectors over time. And MARS consists of 4 main components, which are summarized here. The first is detection and attribution, where we will use satellite observations to identify emissions events. Then in component 2, we will notify the relevant stakeholders by informing companies and governments of the event. And following the notification, stakeholders will take action to address the source of methane. MARS, IMEO will provide information and connections to support them to mitigate the event. And finally, IMEO will document all of the data and actions within the MARS system. We'll also seek feedback from operators and other mitigation partners regarding the system performance so that we can improve over time. For component 1, there are already several satellites in orbit today that can measure methane emissions in the atmosphere. I think this graphic has already been shown. And it has been described. There's 2 types of satellites. They're the global mapping satellites and then the high resolution satellites. So MARS is combining these 2 types of satellite data together to identify methane hotspots. Through this process, we're working with our partners at the Netherlands Institute for Space Research and also KAIROS to implement the satellite detection and attribution system. So here's an example of a high-resolution plumes from ASI's Prisma satellite and from ESA's Sentinel-2 satellite. And by comparing the satellite data on methane with the visual imagery and available databases of infrastructure and ownership, such as from the Oil and Gas Methane Partnership 2.0, MARS is able to connect emissions directly to facilities and facilities to operators. So this ability to successfully localize emission sources hinges on the information that we have about facility locations and types. So the more information that we get from companies who join Oil and Gas Methane Partnership 2.0, the more successful we will be. Once an emissions event has been detected, MARS uses a 2-step notification process to inform relevant contacts about the emissions. We are designing systems to get this information to the right stakeholders as quickly as possible, using a collaborative and transparent process that leads to mitigation. MARS will work with partners throughout this process, including connecting these stakeholders with mitigation support when possible. And in particular, we've designed MARS in collaboration with the International Energy Agency and the Climate and Clean Air Coalition. As part of IMEO, the goal of MARS is to promote global transparency on methane emissions and drive meaningful action towards mitigation at the speed and scale necessary to achieve the Paris Agreement. To that end, MARS' objective is not to point fingers, but to serve as a platform through which the global community can cooperate to identify and address the biggest sources of methane emissions. This is why IMEO encourages active participation in the MARS process. The engagement and collaboration between companies, governments, and other partners will be captured and documented in the data platform and made public after detection. And proprietary data provided by companies will not be released. The UNEP launched IMEO at COP27 to support countries to reduce their methane emissions and meet the global methane pledge. And we're launching the Mars pilot at the beginning of this year. So we're still in the pilot phase. And fortunately, to date, we've already documented a few case studies of identified emission events and launched subsequent notifications. And in at least one of these cases, there's been a successful mitigation action, which has been confirmed by an operator and verified by our continued monitoring of this location. This pilot phase presents an early opportunity for countries and companies to engage with Mars to help shape the system processes and procedures. During this time, data will not be publicized. In the second half of the year, Mars will become fully operational and data will be made public within 45 to 75 days after a detection. And as new satellites come online, their data will be integrated into the Mars process. This will enable Mars to identify lower emission events as the satellite detections improve over time. And we do hope to expand to waste and agriculture once we have the technical feasibility to do so. This Mars pilot phase provides an opportunity for countries and companies to engage with IMEO to co-design the system and make it as effective as possible. We would like to invite governments to partner with us and our partners at the Climate and Clean Air Coalition to identify the focal points that should be notified in the case of an emissions event. Having a dedicated focal point in your country will lead to faster mitigation action. So we look forward to working together and to take action on methane emissions. Thank you very much for your attention.
Good afternoon, everyone. My name is I'm from Department of Environment, Bangkok Metropolitan Administration. For today, I would like to thank you, the organizer, for giving me an honor to be here and share with you on the presentation related to the air quality fact in BMA school, as it is connected to the monitoring and action. Yeah, let me start with the PM 2.5 is far from methane. Today, I present for PM 2.5 situation in Bangkok. In Bangkok, the PM 2.5 concentration normally it's followed for season trend, and during the dry season from November to February. In this period, followed by the summer season beginning in March, and often fluctuate situation in that time. And also, if you look at the data, you show you this graph show you the result of the PM 2.5 concentration. In this year, we found that the lowest is 7 microgram per cubic meter, and the highest one is 133 cubic meter in 1st February. As you can see, it's the highest one. And the next, I will share with you on the location of the regulatory air monitoring system in Bangkok. If you look at the blue one, the blue one is the map of the Bangkok. In Bangkok, we divided in 50 districts. In 50 districts, we installed the regulatory air monitoring station for 70 stations for regulatory. And if you look at the red one, it is the type of the monitoring station. It is the type of the it's like a container station, and I will let you know later. And totally all 70 stations covering in 50 districts in Bangkok. In area of Bangkok is around 1,569 square kilometers. It is the total area of Bangkok. And this this picture I would like to share with you on the type of the air monitoring station in Bangkok. And the regulatory air monitoring station in the first I would like to share you. The first one is the compact station. This compact station is a measure for PM 2.5 and also PM 10. And the next one is we have a 4 container station located in inner area, in inner city. It is in this station measure for PM 10 and also PM 2.5 and nitrogen dioxide, CO2, CO and ozone. It is for container station. And the next is the outdoor. The outdoor station is we located in 23 station. This measures only PM 2.5. And the next is the outdoor station. It is station consist with a display board located in a public park in Bangkok for 20 public park. It is station measure for PM 2.5 and also display every hour in the park when the people go to for exercise and like have activity in the park. They can see the air quality in that park. And also we have a mobile unit for PM 2.5 for unit, and also the oldest one is we operate in 2008. Just this one is can measure for PM 10, but cannot measure for PM 2.5, and also it can measure for VOC and also NOx and SOx and also ozone and butadiene too. And this like to the station at we collect and aggregate the data before we inform information to the people. Sure. And I will move on to the data center of the Bangkok air quality. It is a center we established this center in 2018. 2018 and located in Bangkok City Hall in this show you this building. And in this center it function as to aggregate the data from the 82 station. The 82 station is belong to BMA 70 station, and 12 station is belong to Pollution Control Department, Ministry of Natural Resources and Environment. And BMA collect and aggregate the data for 82 station as located in Bangkok, and get the result to share the information and communicate to the people. And the data center function as a monitoring situation and assess the air quality situation that may affect to the public health. And as I let you know, communicate to the people. This is an important function of this center. And according to the national PM 2.5 national plan of Thailand, BMA conduct PM 2.5 action plan. This plan we declare every year, and to collaborate with the relevant agency to solve the problem and mitigate the impact of PM 2.5. And the PM 2.5 action plan of BMA, we divided in 3 measurements. The first one is monitoring and disseminating information to the people. And the second measurement is eliminate PM 2.5 as thought by inspection pollution as such as cement plant. In Bangkok, there are around 129 cement plant in Bangkok, and also construction site. Moreover, in the provincial nearby Bangkok, like neighboring in border of Bangkok, and also in some district in outside is Bangkok. It's like farming, and we have we facing of open burning too in the period of the time in summer. And third measurement is the prevention and public health care. BMA, we have BMA hospital under BMA administration. We provide a pollution clinic in BMA hospital in the period of the PM 2.5 crisis. And also we install a purifier in preschool, and we conduct I will share with you today as we conduct the air quality fact activity in BMA school. In Bangkok, we have the school in Bangkok around 1,500 school, and the school is under BMA administration is 437 school in Bangkok, and this school is BMA initiate the student to implement the air quality fact activity to get the student to learn how to know how to access the data and how to protect themselves. And this show you the activity of air quality fact in BMA. According to the Bangkok governor, Ajahn Chacha Sitapan, as you may know, the Bangkok governor policy to tackle air pollution in Bangkok by collaborate with all agencies. And in terms of connecting monitoring to action in this area of the PM 2.5, BMA implement air quality flag in BMA school, as I let you know, and the air quality flag in BMA school as a symbol to convey the meaning, the color of the flag representing the air quality index related to PM 2.5 concentration, and the student easy to understand and be able to take care of their health and their family, and we do hope it can expand to the community. It is our objective of this project. And the first step of the implementation of this activity, the Bangkok governor has issued an announcement. This is announcement last year for the school to air quality activity. And this announcement is seem to emphasize the importance of the policy level to acting for the way to mitigate the impact of the PM 2.5. And then after the Bangkok governor announced the activity, and Department of Environment, we organized the meeting for school administrator and teacher to inform the way to access the PM 2.5 situation from regulatory air monitoring station nearby the school to the application and website of Air BKK. This is application related to the data center, and the teacher to teach a student to implementing air quality fact activity correctly. It is the way to we try to inform them to access the correct data before they implement the activity for quality fact in their school. Yes, and this slide show you the activity of air quality fact in BMA school, and sometimes the teacher and student make an activity about air quality in classroom, and sometimes mid-morning activity before class. And it show you the picture. Yes, something like that. Yes. And also in this year, BMA is underway to proceed to expand the air quality fact activity to private school, and also the school is under Ministry of Education to get the student to learn more about the quality and also the impact of the PM 2.5. It is our target to increase in this year. And the important one is the communication channel to publicize the PM 2.5 situation to the public. And we found that we have many channels for people can get LINE. For example, LINE alert, we connect to LINE alert company, and also alert in case of the PM 2.5 is high concentrate and can affect the health to the people, and alert to the people in Bangkok, and also people is outside Bangkok can get to. And the popular one is Taffy Fondue application. It is Taffy Fondue application. It is the Bangkok governor encourage the people to to use in this channel to give advice and also to compare, and then BMA can tackle the problem in this many the channel as BMA try to provide for the citizen to communicate and to work with the BMA and to give advice to it. That's all of my presentation. Thank you.
Thank you very much. We have one more presentation. It will be virtually. I don't know if we can have the connection established.
Yes.
Hello.
Hello. You can
Abraham?
hear me? Yes.
Yes, we hear you.
Okay. Thank you. Thank you very much. Yes. Thank you very much to all the people in the ground. Unfortunately, we could not be there. I want to show from a Mexican perspective the things we are developing. In this case, I would like to, my colleague from is a postdoctoral researcher is working with us in the National Institute of Ecology and Climate Change, Helen Padilla, will explain with more details what we are doing. So, first of all, I want to say that the previous presentation showed that many of the things that we are developing in the same way, talking about inventories, talking about air pollutions. I will not give more details about that. I will give some examples of the things that we are doing and what we are focused for the next steps and what we are looking to doing with satellite information. And you can do it, please, Helen, go ahead. Thank you.
Hello, everyone. Do you listen to me?
Yes,
Hola?
we hear you.
Okay. Okay. Sorry, I was just checking out. Okay. Well, hello, everyone. This is one of the examples of what we were doing recently. Well, this is in 2020. We were comparing the NO2 column density in 2020 against 2019 to check this industrial area. There are several places that we were checking out by measuring checking with the satellite data from Tropomi, but these places were something that we were interested because this is industrial area. This is about to be declared as an emergency environmental, and that's why we were interested here. So we could see the change exactly of the NO2 column density against the 2020 against 2019. So that was one of the applications that we could see or we were using, because we also this analyzed for Mexico City and all the big urban areas that are in the surroundings in Mexico City. We are also were exactly checking out the formaldehyde in 2019 and in 2020, because we use the formaldehyde as a proxy of VOCs, because, well, in the air quality in situ, we are not measuring the VOC. That is a problem that we have. So we use the formaldehyde from the satellite, from Topomi, as a proxy to check out the VOCs in the areas. The next one, please. Well, this is another example that we are working actually right now. Is a way to check the atmospheric basins to manage air quality, because on the down right, for example, we can see an image of NO2 column density from Tropomi 2, and we can see in the center is the urban area of Mexico City, but in the surroundings are these big urban areas like Toluca, Cuernavaca, and at the north we can see a place called Tula. So all this basin, atmospheric basin, is connected. So at the end, to take policy decisions, we consider that these policies should be taken considering all this large extension. So we were analyzing this type of atmospheric basins by satellite. We have the same example on the top right is Monterrey. On the right side, we can see the urban area of Monterrey, but on the left side is Saltillo. So these atmospheric basins are already connected. So if the air quality policies are just taken for just this one limited area, well, it's not enough, because the atmospheric basin shows that exactly these two atmospheric basins, we can say, are already connected. So to manage the air quality in a better way, we should consider that these big urban areas are already connected. So we have the same case here in Tijuana on the border. We have in the center, this hotspot is Tijuana, the urban area, but is already connected with San Diego. So it's a point to consider that exactly we should extend all this analysis for these big atmospheric basins. The next one, please. Click it, please, because it has animations. Thank you. Okay, another application that we were using the Tropomi data is to see methane, to see the atmospheric density, and we see on the territory that we have kind of several hotspots, like Tijuana, exactly. On the northern part, we have also the northern part of Mexico, and the middle of the country. In that part is Mexico City. But lately, we were more focused on the peninsula of Yucatan. The next one, please. Here we were more focused on in the peninsula of Yucatan, because the peninsula of Yucatan has several problems, and we were we are affronting this one by one. And one of these is the methane emissions, the ammonia emissions, and we were in situ measuring the methane air concentration and the ammonia air concentration. But we also used the Tropomi data to check exactly the column density of methane. And we could see that the hotspot is in Mérida, in this case, in Yucatan. That is the capital of this state. So it seems that the hotspots in this area are related to the concentration of population in this area, and the rest of hotspots are exactly the same. People are living there. So, but because we were measuring in pig farms, in chicken farms, to see these methane air concentrations, but the hotspots are more in where people are living in these places. So we could see that we are still analyzing this. Is a problem that we are concerned these last months. So we continue analyzing the satellite data from Tropomi, and our goal is to extend this analysis for the whole peninsula of Yucatan, and we will see. One thing that we had a problem is we couldn't see the methane on the sea. We know that there are the oil platforms, and we will see in the next slide. But with methane, because from Tropomi we could see it on the sea, so we could see it just on land. But this is something that we were doing exactly because we are also interested in sulfur dioxide. The first image is from May 2022, and the second one is from May 2023. So, for example, we can see the hotspots. One is on the sea on the Gulf of Mexico, is the oil platform. The second one in the peninsula, is in Tabasco. And in the center of the country, we have exactly the generation of electricity in Tula, and we also have the Popocatépetl. That is the biogenic source. And obviously, in this month we have more because the volcano is in activity now. So, but the hotspot continue there, and but now we have the deviation of SO2 because exactly due to the volcano, the column density of of SO2 is now 5,000, and the last year it was 2,000. So obviously here we can see that our biggest contribution is from the volcano, but from the anthropogenic sources, we have exactly the hotspots from Gulf of the Yucatan, and this from the generation of electricity from these oil platforms. The next one, please. And we also were working from using data from Landsat and using the database from Hansen, and because we wanted to see these last years the government is building a train line in the peninsula of Yucatan. So in order to see the deforestation yearly, we wanted to check it out using this data from Landsat. And we can see for the whole peninsula of Yucatan on the top right and on the top left, we can see that the biggest, the major deforestation was in 2020 during the pandemic, and you can see it so far, and in 2009. But to check out exactly the deforestation on the train line. On the train line, we also did this analysis, and we could see that like in 2021, it was the major deforestation for this construction for the train. So we are also analyzing.
So, if you can wrap up in 1 minute, please.
Yeah. So we are also checking other areas for deforestation because the area is very, very affected for several things. For crops, bees are also affected. We have these methane emissions, all these things. So we are also working. We are working with satellite data. We would like to have more access to the methane data from other satellites because that will improve our analysis. Well, thank you very much.
Thank you, Sue Ellen, and thank you, Abraham, for being awake to give this talk. I think it's like 3 or 4 in the morning in Mexico, but anyway, thank you very much. Very well received your contribution. Now we have really not so much time, but I really would like to turn the word now to our other panelists and ask them generally what their impression is to all these tools that we have. The table seems to be set, no, to really make action, and then really how countries can really take advantage of these methodologies in order to reduce the emissions.
I think that last statement is such an important piece, and I think it's where we're at and struggling also right now is for countries. There's a lot of shiny new toys out there right now. And it's trying to figure out how to use them. We have not quite figured out, at least in the methane space. I mean, what Mexico was showing right there with deforestation. Obviously, that's a tool that can be used right now. But in the methane space, with what Ilse was showing, what Marcy and Kinsey were both showing. We have not quite figured out exactly how to use these new tools. And I think part of it is that the shiny new toy is the satellite, but that's not really what we're talking about. The title of this is remote sensing. And when we think about how this will have to be used, it's in the lines of what Kinsey was presenting. This is this this suite of tools that can be used to inform policy. And I think it's extremely important that we focus on that. In the early days of the excitement around satellites, we were working with a country in South America who was considering using satellites, the existing satellites, for its leak detection and repair program. And I think there's that kind of excitement that has to be grounded in the realities of what's possible now and what will be possible in the future. So I think focusing on that suite of tools that can be used to ameliorate the situation, I think that's going to be critical. But there's going to be a tremendous need for education and capacity building within governments so that they are prepared to take this on. And then, another big piece that we have not yet dealt with, and I know it's on Marcy's list of things to deal with and everybody's list to deal with, is we're going to be generating a lot of data that's not going to mash up with national inventories at all. And we haven't quite figured out how we're going to suddenly take things that have nothing to do with how inventories are created, which aren't created from these on high emission measurements, how we're going to integrate those into national inventories so that we can truly begin to track methane emissions in the inventory. So I'm going to stop there because I know we're completely out of time here, and I want to make sure that Sergio gets a chance to talk too.
Really, really important comments, but more questions than answers. Sergio, what are your impressions?
Well, we have very little time, but I cannot resist to make a kind of comparison of our profession to address climate and clean air issues to the medical doctor's profession. So at the extent they have more instruments to understand the problem at different scales and at different parts, it's much better to have a better diagnosis and to come up with better solutions. This is the way I would like to see these technologies we are discussing, specifically about remote sensing. And at that extent, we should also recognize what are the challenges we need to face, not just the limitations, but for what we need to be prepared for. We need to be prepared for understanding that the data we have on the ground is limited. That also hinders the extent in which we can compare and complement with remote sensing. The difficulties that we are still having in terms of emission inventories to identify specific sources, the complexities that implies the processing of data, and perhaps the need also to create hubs, units, technical support in order to help countries and cities and other users to use this information, and the lack of underground measurements, specifically in the area I mostly work, that is air pollution. Well, there are countries that are not even measuring air pollution underground. There are no air pollution monitoring stations. In Latin America, for example, there are just 9 out of 33 countries that are regularly measuring air pollution. And inside those countries, not all the places in which air pollution should be measured are measuring at all. So how we can address these issues? If we do it jointly in a collaborative fashion, we can work better. So the CCAC can be supported, can rely on the participation of different partnerships that are happening. Nathan has been repeating several times that for the first time in history, we have collaboration frameworks in different regions around the world. So there is a need to develop capacities, to provide technical assistance, to develop data sharing platforms, facilitate knowledge exchange, and foster more partnerships and networks. And by joining these efforts to share this and to understand better the needs, the particular needs of the regions and the cities and countries and other stakeholders, we are going to do better in using these technologies, and many other things to say, but I would like to stop there because I don't want to take too much of the rest of the evening. Thank you.
Thank you, Sergio. Yes, we are on the hour. Actually, I wanted to open the floor to the audience, but I think we are on time. I just wanted to wrap up by saying that it's really exciting to have these shiny toys, like you mentioned. But we really would like to see a follow-up of more successful stories like the ones you mentioned in California, and see whether this really, the whole step-by-step method is followed into really have mitigation stories and good successful stories to tell. So I think this will be the subject of future meetings, no? To show you not only the nice toys and the procedure that what we want to follow, but also real values of how much we are mitigating with these technologies. Yes, Sergio.
I'm very sorry, but I was about to forget something. EDF and UNEP launched a partnership last year for the Latin American and the Caribbean region. We are in the process of identifying project profiles in which we could invest efforts in order to develop success stories. And it would be great to really start integrating these tools in actual projects that could result in a better understanding, but also in identifying what kind of solutions could be derived and what is the added value of putting together these tools. So it's just an invitation to discuss further on how we can join efforts.
I am very optimistic, really. I mean, the will is there. We have seen some example of countries who are doing real progress in monitoring or using satellite data, and I am very optimistic that we will move forward in this. With that, I just want to thank again the speakers for really excellent presentations, and all of you to stay this session, at the last session. I would like to ask you for a round of applause to our speakers. And with that, we're closed for today. Thank you very much. I don't know if there are any other announcements to be made, but probably the organizers left already. Thank you very much. Have a good afternoon.
There's a cocktail at the Asia Pacific foyer. It's on the ground. It's on the ground floor to the left of the eating area. If you want to go now, thank you.
Yes.
We run out of time.
I know it's only okay, but yes.